this agent's got some bones sticking out the back of his head, which we're going to use as hair, or a ponytail anyway. Now, that doesn't look much like a ponytail. We need to switch on dynamics. So we bring on an output node and we type in dynamics.active and set it to 1. But that's probably not what we had in mind. So we need to set dynamics on for the hair 1 bone, which is the first bone in the hair. So let's change this string now to say hair 1 colon dynamics.active. Now what have we got? Probably also not what we had in mind. And that's because when you switch on dynamics for a particular segment, it becomes effectively unparented from its parent because the dynamics doesn't know about the parent. So what we have to do is add a spring to attach it back to the parent during dynamics. And a new spring will be by default attached to the root, so we just disconnect it from the root and we attach it to the hair. Now that's all we have to do for attaching it, and then we switch on parent. We change it from being a normal spring to a parent spring. This is a special kind of spring used for constraining a segment to its parent. Alright, now we've got no change at all because we've got no translation force. Okay, so let's try a force of 1,000. Well, that's an improvement, but it's still not quite right. Let's put another 0 in there. Okay, now we've got our hair successfully attached to our head. But it's a little bit loose. Maybe we want to make it so that it's keeping a better rotation in relationship to the head rather than just flopping around. So we can adjust the Rx, Ry and Rz forces for the parent spring. Okay, that's better. That looks pretty much like a ponytail should. But what if we wanted to make something more like a real tail rather than a ponytail? Well, we could of course just increase this force here, which would make it more rigidly attached to the parent. Oh, but then our dynamics are getting a little bit wiggy. So what we'll do is we'll click on the background to get to the agent parameters, click on dynamics, and we can up the number of steps per second here. Alright, we'll set it to 1500. Now that's a little bit more stable, but we're finding that the first bend along the hair is a little bit loose, and that's the hair 2 bone. Well, what we need to do is we need to make all of the rotations for the dynamics segments a little bit stiffer, and we can do that by going back to agent dynamics and setting a force for the rotation limits. Now that force is used to keep the segment rotations within the limits that are set for that segment. But first we have to actually set those limits. So let's select hair 2, then go into the DOF tab, and we'll notice that the limits are by default -infinity to infinity for Rx, Ry and Rz. Let's set them all to 0, 0. And doing this doesn't affect anything else because the limits for a segment are only referred to in the dynamics. Okay, now we can adjust this force. Let's try 1000. Well, that's a little better. But we're finding that the first joint is still a little bit loose. So we can adjust the parameters for that joint independently of the rest. You'll notice that many of these parameters in dynamics have an inherit flag switched on. If we switch it off, we can then adjust this parameter for just this segment. And that gives us something more like what we wanted for tail dynamics. Now when we save our agent, we save all of the dynamics parameters along with it in the CDL.